Okay, welcome back. This is Mr. Hassan's Math Channel. I'm now answering question number 9 from the Pure Mathematics P1 International A-Level Edexcel June 2022 exam. This question here is about trig graphs. It says figure 4 shows part of the graph of the curve with the equation y equals sine x. It says given that sine alpha is equal to p when alpha is between 0 and 90 degrees, state in terms of p the value of, and then they've got some questions to deal with. So 2 sine 180 minus alpha is the first one. So basically alpha is an angle between 0 and 90. Now in the sine curve you got 0 degrees, of course, over here, and then this is 180 degrees and this is 360 degrees. And this is negative 180 degrees, and this is negative 360 degrees. Okay, we should know how the sine curve goes. We also should know that it reaches a maximum value of 1 and a minimum value of -1, and it doesn't go above or below that for y equals sine x. And the maximum, the first time it reaches the maximum is at 90 degrees, and then again at 270 degrees. That's when it reaches the minimum, sorry. And so the maximum is at 90 degrees, the minimum at -1 at 270 degrees. And then it reaches -1 again when you've got the angle as negative 90, and then here negative 270. All right, so now it says, given that sine alpha equals p, where alpha is between 0 and 90. So they're telling us that alpha basically is an acute angle somewhere between 0 and 90. So I'm just going to draw a random line to show where alpha is. Let's say alpha's over here. Okay, I'm just putting it any old place. Just say that's alpha. Okay. Now that means that p is the value that we get up over here. That's what p is. That's where p is. Let me just make that thinner. Okay, so that's p. All right, so that's alpha, and that's p. All right, okay, now it says state in terms of p the value of 2 times sine 180 minus alpha. Okay, so this kind of question here we can deal with in terms of transformations of the point here. Now, the problem with dealing with this with the transformations of the point here is because this is like a combination of transformations. What's happened to the alpha? Well, you've got it's multiplied by -1 and 180 is added to it, and this is inside the function, so there's a particular order that you've got to go by. It can become a bit complicated. So the easiest thing to do, I think, is to deal with this in terms of, let's try to pinpoint where the angle 180 minus alpha would be. Okay. Now, I'm trying to explain this in a way that does not require any knowledge from P2, all right? Because if you understand, or if you know how to deal with trig from P2, then this is pretty simple, this particular part. I'm trying to explain it in a way for those students who haven't looked at P2 yet, because this is a P1 exam. Some people take this exam, before studying, this trigonometry in P2. So I'm trying to explain in a way that requires just P1 knowledge, okay? So, if you do answer it using your understanding of what's in P2, that's absolutely no problem. But I'm just trying to stick to the explanation that involves only P1 understanding. Now, basically what it is, if this is alpha here, as we drew earlier, if this is alpha here, okay, let me straighten that up. I don't think it's straight. Okay, if that's alpha, still not straight, 1 second. Okay, that's better. If this is alpha, okay, so this distance between that and that is alpha. So I'll try and make this clear. This distance is alpha. Okay, now 180 minus alpha, well, this is 180, as we know. Over here we have 180. This is 180 degrees. 180 minus alpha is going to be basically, copy, paste. Okay, it's going to be basically over here. That's 180 minus alpha. Okay, and if this is, we know that this curve is symmetrical. So what we need to know is that the sine curve is symmetrical. Okay, the sine curve is symmetrical. That's what we need to know. Okay, so if that's 180 here, then this, if this is alpha, that means that length is alpha from there to there. That must also be alpha because it's symmetrical. The sine curve has this symmetry, and that's one thing that we should know from our understanding of the sine curve from P1. All right, so that's also alpha, that distance. Therefore, the angle at this point here, that angle there, is the angle 180 minus alpha. So the sine of 180 minus alpha is going to give you exactly the same value as the sine of alpha. That will give you exactly the same value of P. Okay, so we can say that the sine of 180 minus alpha is going to be P, and 2 times that is going to be 2 times P. This is going to equal 2 times the sine of alpha, which is 2 times P. So there's the answer. Okay, we can think of it as this is a vertical transformation. It's, you know, all the y values have to be multiplied by 2. All right, so you'll end up with 2 times whatever P is. Okay, so if sine alpha equals P, then 2 sine 180 minus alpha is going to equal 2 times P. All right, it's going to be 2 times P. It's going to be the same level here, the same value of y, but just twice. You have to multiply that by 2 because this gives you the same as this. Sine of alpha and sine of 180 minus alpha give you the same value. Okay, and from P2 knowledge, we know that if you know that the sine of an angle, if you know the sine of an angle, then the other angle which has the same sine ratio as that angle is 180 minus that angle. That's how you find the first main angle. That's from P2. All right, so that's how we can deal with part A, part 1. Now part 2 says the sine of alpha minus 180. The sine of alpha minus 180. So let's try and think about this in a similar way. Now if this is, and by the way, we can also check this answer. We can, for example, choose alpha as a random number. So supposing I chose alpha as, say, 30 degrees. Okay, just a random number that's between 0 and 90. Okay, so I can say 2 times the sine of 180. Well, first of all, we find what the sine of 30 is. So we know that, I know the sine of 30 is a half, but just the sine of 30 is equal to a half. And if we find what the 2 times the sine of 180 minus 30, that should give us 1 if we're correct, because it's 2 times what that value is. And we got a half, so that's going to give you 1. We know that the sine of 150 is also a half. 2 times a half is 1. So it works with this number that we have just decided to test it with. Okay, so similarly, we can do something with this. We got sine of alpha is the sine of alpha minus 180. So now let's take our alpha there. Then of course the P is going to be here. Okay, so that's alpha and that's P. Straighten this up again. Okay, so there's alpha and there's P, and this is 180. Okay, and this is minus 180, and this is minus 360, and so on. Okay, now what alpha minus 180? So basically you're alpha and you got to go back 180. Okay, so basically what we're going to do is we're going to go back to, this is like, you could say this is the same as minus 180 plus alpha. So yeah, minus 180 plus alpha will be over here. Okay, so it's the same kind of idea. We can take this and we're going to be over here now. Okay, the curve goes down at this point. So this is the angle. This is the angle alpha minus 180. It's like minus 180 plus alpha. Okay, this is where the angle is. Okay, now from the symmetry of this curve, this has got symmetry. This distance and this distance is the same. Okay, you have this symmetry. Okay, so therefore this value here, it's not going to be P, but it's going to be the same distance as P is from the top underneath it. It's going to be minus P. Okay, let me just draw that straight. So here we're going to have a negative p. So we can use the symmetry of this curve again, and we can see that this is going to give us minus p. Okay, this is the same as the sine. Well, we got it there anyway. So it's going to be equal to negative p. Okay, it's going to be equal to negative p. All right, so the sine of alpha minus 180 is equal to negative p. And again, we can check to see if our answer is correct by using the calculator. And we can say, you know, as we said, sine 30 is equal to a half. So let's do sine of 30 minus 180. And that's going to give you negative a half, which works out. Okay, so we can test it with a random acute angle to see if it works, if our answer actually does, you know, make sense. And then the part 3 says find the sine 3 plus the sine of 180 plus alpha. Okay, so now let's do the same thing with 180 plus alpha. Now 180 plus alpha, again, if alpha is over here, if that's alpha, okay, and that's p. Okay, so you have p and alpha. Now this 180 plus alpha will be basically the same as this, but just over here. Okay, and again, from the symmetry of the curve, we can see that this distance is alpha, that distance is also alpha. So this angle here is 180 plus alpha. And we can see, again, it's going to give us negative p. It's going to give us negative p. So this is going to equal 3 plus negative p. Okay, so it's 3 minus p. All right, so that's the answer, 3 minus p, because we've got to add 3 to it. All right, we've got to add 3 to it. So it's 3 plus, this is negative p, so 3 minus p. And we can again test the answer by using, for example, again, 30 degrees. We could use even any acute angle. Let me just use 60 degrees just to show you. For example, we know that the sine of 60 degrees equals root 3 over 2. Okay, and let's do 3 plus the sine of 180 plus 60. That's going to give you 6 minus root 3 over 2. Okay, that doesn't show it very clearly, but we can show that 3 plus root 3 over 2. Okay, 3 minus root 3 over 2 is the same as this. Okay, because this is going to be 6 over 2 minus root 3 over 2, which is 6 minus root 3 over 2. So it's the same thing. Okay, so this is the same as 3 minus root over 2, 3 minus p. So the sine of alpha, the sine of 60, we chose 60 as a test here. The sine of 60 is equal to root 3 over 2, and 3 plus the sine of 180 plus 60 gave us 3 minus that, basically. Okay, we can try it. We can use sine 30 again if you want to make it more clearer. So you have 3 plus the sine of 180 plus 30. Okay, and you can see that gives us 5 over 2, which is 2.5, which is 3 minus what sine 30 is half. 3 minus half is 2.5. I think makes the numbers are a bit easier. That makes it clearer. But we can see that we've got the right answers. So we've used the symmetry of the curves in order to solve these problems, rather than using some sort of trigonometry from P2. And now for part B, it says on diagram 1, sketch the graph of y equals sine 2x. What we have drawn is y equals sine x on the graph. So we should know, therefore, that the coordinates of these points are as follows. This is 0, of course. This is 180. Here we have 360 degrees. Here we have negative 180 degrees. And here we have negative 360 degrees. And we know that the maximum point is reached at 90 and the minimum at 270 on this side. And here the minimum at negative 90 and the maximum at positive 270. Okay, so those are some of the points, important points that we need to know. Now, the y equals the sine of 2x. Y equals the sine of 2x, which is basically y equals f2x. What's drawn is y equals f of x. Now, this is where the x inside the function is what's multiplied by 2. Okay, it's inside the function. It's not outside the function. So this causes a horizontal change. Okay, a horizontal change. And horizontal changes are always, a bit strange. For example, if you had, for example, x plus 30 inside the function, say, then all the x values, you would subtract 30 from them, not add 30. Okay, and similarly with this kind of multiplication, when this is called a stretch, when it's f of 2x, then you multiply the x values by a half. You multiply by a half all the x values. So all the x coordinates of all these points are multiplied by a half, and the y coordinates stay exactly where they are. So for example, this point 91, the point, of course, 0, 0 stays as it is. It doesn't change because you multiply 0 by a half, it stays as half. Okay, so the x values we're multiplying by half. Okay, and the point 91. Now the y value stays as it is, but the x value is multiplied by half, so it becomes 45, 1. And 180 0 becomes 90, 0. And 270 negative 1, it becomes 135 negative 1. The y values don't change, the x values are halved. And 360 and 0 becomes 180 and 0. And similarly on this side, okay, negative 91 becomes negative 45. So negative 90, negative 1, negative 45, negative 1, and so on. So basically, the maximum point is going to move to 45 degrees. So I'll mark that here. The maximum point is going to move to there. It's going to go through that point. And so that's the 180, the 270, the 180 is going to go to 90. It's going to go through here. The 270 is going to go through 135, which is going to be over here. But it's going to be down here, sorry, in the negative minus 1. So it's going to be down here. Okay, somewhere. So that's going to be up here, 1. That's going to be down here, negative 1. So this is going to be down here, 135, negative 1. And 360 is going to end up over here. So the first part of the curve will look something like this. Try and be as neat as you can. Okay, it's going to look something like this. Be a sine curve. Okay, so it looks something like that. All right, not exactly perfect, but something like that. Now that's just going to repeat again. That same pattern is going to repeat again. So it's going to go through these points here. It's going to go exactly the same pattern, repeating again up to 360. It just repeats every 360 degrees. Well, in this case, every 180 degrees, because you can say its period has been halved. And same thing with this, it would normally go through negative 90, negative 1. So it's going to go through negative 45, negative 1. That's negative 45. And instead of going through 180 and, 0, it's going to go through 90, negative 90 and 0. Instead of going through negative 270 and negative 270 and positive 1, it's going to go through negative 135. Negative 135 and positive 1. Instead of going to negative 360 and 0, it's going to go through negative 180 and 0. So it's going to be a similar thing on this side, but just over here like this. That same shape, repeating. And it's going to repeat again like this. The same thing is going to happen on this part. It's going to go through these same points. I made that a bit lower than I should have, I think. But you get the idea. That's supposed to be at minus 1. Okay, so it's going to do the same thing on this side. Make that a bit neater. something like that. I haven't drawn it exactly perfectly, but that's okay. Okay, so that's the sketch of y equals sine of 2x now. Okay, the blue line. All right, so there we have part B. Everything is basically squashed. So the normal pattern that it repeats is now not every 360, it's every 180. Okay, that's sine of 2x. It says, hence find in terms of alpha the x coordinate of any points in the interval from 0 to 180 where sine 2x equals p. Okay, so now remember alpha is an acute angle somewhere between 0 and 90. Okay, so now it says find in terms of alpha the x coordinate at any points in the interval 0 where sine 2x equals p. So basically, if we think about alpha anywhere in this area here, it doesn't matter where, okay, before we get to 30, it doesn't matter where you do actually, you'll see that what's going to happen is you're going to have between 0 and 180 up to there. I'll just extend this so we can see more clearly. Okay, any angle between 0 and 90 degrees is going to have two solutions between 0 and 180. Okay, and those two solutions in terms of alpha, okay, the x coordinate. So all right, so you're gonna have here alpha. This will be alpha divided by 2. Okay, whatever alpha was, it's divided by 2 now. Okay, you can see that whatever alpha was before, it's divided by 2. Okay, sine 2x equals p. Remember, the sine of alpha was equal to p. Okay, so now we're going to have alpha is the same as 2x. Okay, so alpha is the same as 2x. That means x is now alpha divided by 2. So the x coordinate we're going to get is half of what alpha is. All right, so that's going to be alpha over 2, and this value is going to be, well, before it would have been, the answer would have been here. So before, see, the sine of alpha would have given us this value here. This would have been equal to p. Okay, but now what's equal to p is alpha over 2, half of that. And before, the value there would have been 180 minus alpha. That answer was 180 minus alpha, the one that we had over here. So now it's going to be 180 minus alpha over 2. So we can say x is going to equal alpha over 2, and x is going to be equal to 180 minus alpha divided by 2. Why? Because if we look at y equals sine x, the two solutions are here, which this is alpha here, and this is 180 minus alpha. So this value is alpha, and this value is 180 minus alpha. So this value, then the value where it now hits the new sine, the sine 2x, is going to be halved. So this is going to be alpha over 2. This is alpha over 2, and therefore this value here is going to be, where it hits it again, is 180 minus alpha over 2. Okay, it's going to be a half of this, because everything, the x coordinate is multiplied by a half. So these are the two solutions for part C. Okay, so I hope that was clear. All right. Yeah, this is one of those new type of topics where we're dealing with a sine curve. All right, so I'm trying to explain it, as I said, in a way that does not involve our understanding of P2 trigonometry. With P2 trigonometry, this will be very simple. All right, but if you think about it as, okay, the sine of alpha is equal to P. All right, so that's the point where they intersect. Okay, that point over there. And because this is sine of 2 alpha, all those values have to be halved. The x values are halved, so it's going to be alpha over 2. That's where it's going to intersect. If it was a sine of alpha, the sine of alpha equals, the sine of alpha, this is the other value, sine of alpha equal, we worked out that that's the sine of alpha equals 1, the sine of 180 minus alpha equals p over here. The sine of 180 minus alpha, that's where the x value is 180 minus alpha. That's the other time where it hits the curve at the point P. Okay, the line y equals b hits this curve again at 180 minus alpha, as we determined from the first question. So when it's sine of 2x, it's going to be, that x value is going to be halved, so it's going to be 180 minus alpha divided by 2. Okay, so I hope that makes it a bit clearer. So that concludes question number 9 from this P1 exam from June 2022. Other questions from this particular paper can be found in the playlist that will appear in this region over here. Other questions from P1 in trigonometry and trig graphs can be found in the playlist over here. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.